All right. So today, as we said, students, we're doing a class activity today. And the whole aim of the class activity is for us to cement the understanding of transformation. Tomorrow, we're going to practice some more questions. We want to look at some past paper questions, some of the older past paper questions, which are more structured. And then maybe on Wednesday, and maybe even tomorrow, we look at some of the more recent questions. So you see that actually dropping the level of difficulty of the questions. So if we can master the older ones, then we'll be able to do the ones that are setting in recent times even easier. All right, and that is the whole aim of this class, to do the mathematics easy. But as I said, if we're going to do the mathematics easy, you have to do the things that I tell you, like study that must-know sheet and know the items on it. Right, like I am able to write out everything on that must-know sheet of my head and answer any question from that must-know sheet of my head. And that is why I can do transformation questions easily and know the answer to a question before I even do it. Right, and I want you all to get to that level as well. But follow what I tell you, and you'll be fine. And there's nothing on there that you can't know. Right? It is something that I've been using over the years. And students who are very successful in the subject and in the topic are the students who take the time to study those items and ensure that they know those items. So that list was generated over time by studying the structure of the questions. And I realize that those are the items that the questions are centered around, to the extent that if you know those items, then you'll be able to solve 99.9. I'm still not gonna say 100%, 99.99% of those questions easily, and understand exactly what you need to do with those questions. So that is the aim. So even if you don't yet fully know all those items on the must-know sheet, it is still something that I want to continue working on. All right, you need to continue working on those things. All right. So this is the thing that we're working on today, guys. We're doing the questions on these documents today. Right? And how it's gonna go is that I'm gonna explain how the question is to be done. That's why I told you, don't do it as yet. I'm gonna explain to you how each question is to be done. I'm gonna do it right on the left side here. All right, I'm gonna explain how each question is to be done. And then I'm gonna give you like 10 minutes. I'm gonna pause the video and give you like 10 minutes to do it for yourself. But the beauty about it is that you will have the recording. So therefore, even if you don't finish, or if you made a mistake, then you can watch the video over again and then do it the right way. And you will learn from your mistakes. But the important thing is that you do all of them to completion, and you do all of them. And that's a completion, meaning complete and correct. That's what I mean. That's a completion, complete and correct. All right. So that's what this activity today is about. And the aim, again, is to address all the areas in transformation. So we're going to address the translation, we're going to address the enlargement, we're going to address the reflection, we're going to address the rotation, we're going to address the glide reflection, we're going to address the compound transformation, this followed by that followed by this. And these are all past paper questions, but they were specifically selected for this activity because they bring out certain aspects or important things that I need you to fully understand. All right. If you can fully understand these things, then you'll be able to breeze through any exam question. But these are actually exam past paper questions, specially chosen for this activity. All right. So this first one is, I call it finding a rotation example. It's about rotation, right? But also it deals with the compound transformation. All right. I'm going to answer each part. So the question is on this side, and I'm going to do the solution over on the left side. All right, so I'll explain as I go. All right, so the first question here tells us that on the sheet, which is this sheet under here, but I have it on the left side of the page as well. All right, the same sheet. It says, they give us a triangle P, and it tells us to reflect triangle P in the y-axis and label the image Q. So we're reflecting that triangle in the y-axis. So we're doing a y-axis reflection. All right. Now, the important thing to remember for reflection is that you do your reflection 1 point at a time. Don't try to reflect the entire triangle all at once, right? Don't try to reflect this entire triangle all at once. Do it point by point. You're going to reflect this point, reflect that point, and then reflect that point. All right? Do it one point at a time. Don't do it now, no. Just pay attention now, and I'll give you a couple of minutes to do it for yourself. Just pay full attention now. Don't be doing anything right now. All right? So first thing I'm going to do is mark the 3 vertices of the triangle. And then I'm going to reflect each point, 1 point at a time. Image distance is equal to the object distance from the mirror line. Remember, the mirror line in this case is a y-axis. So the first point I'm reflecting is that point at the top. Everybody can see. Let me do it again. First point I'm reflecting is a point up at the top. That is that point. Then I'm going to reflect the point, second point, the one at the bottom there, 1 unit across. There's 1 unit from the mirror line, 1 unit on the other side. So I'll mark it for you can see it. All right? So this point is 1 unit to the mirror line, and it goes 1 unit on the other side of the image. This point is 1 unit to the mirror line, the image goes 1 unit on the other side. So that's how we get those points right there. Then I'm going to reflect this last point over here now. So let's look at it. This point over here, it is 1, 2, 3 units to the mirror line. So it's going to go 1, 2, 3 units on the other side to here. That's where it's going to go. All right, so you do your reflection 1 point at a time. Don't try to reflect the entire triangle all at once. Do it point by point. Then when you have your points in place, then you use a ruler and join the points on the triangle to form the triangle. So you join the points on the triangle now, and that is your image triangle after reflection in the line y on the y-axis. And they say that we have to label it Q. So you write the Q on it, and that is it. You have answered the first part. That's what we have answered so far, right here. First part. All right. The second part now says we have to draw the line y equals x. Draw the line y equals x. Then after we draw the line y equals x, we must reflect triangle Q in the line. So we're going to reflect triangle Q in the line y equals x. And then we have to label the image R. So going from triangle Q to triangle R, a reflection in the line y equals x, and they want us to draw that line. All right, they want us to draw that line. Now, I've seen solutions done by even teachers where they just draw the line y equals x. They know the line y equals x slope up like that, you know. And they just draw something. They just come and just draw something like that. Which is wrong. You cannot just draw something like that. That is wrong. You cannot just draw something. Mathematics is the most exact science. You have to draw the line such that it passes through the correct points. And the line y equals x is the line passing through points like 0, 0, 1, 1, 10, 10. It passes through points where the x and the y value is the same. So you have to draw the line like that. So my line is supposed to pass through 0, 0, 2, 2 right there must pass through this point, which is 3, 3. And then, for example, 6, 6 up there must also pass through -2, -2, and -4, -4. So that's the line I'm supposed to draw. All right, let's look at it. The line I'm supposed to draw is supposed to pass through those points. That's it. Then I label it y equals x. All right, so let me clear this now. So that's what we're supposed to have, guys. And then we're supposed to reflect now in that line y equals x. Now look how the knowledge of the mathematics come into play now. Now some persons would have a difficulty reflecting this in this line. But if you know that when you reflect in the line y equals x, the x and y value interchange. So for example, a point that is xy. When you reflect in line y equals x, it go to yx. And it comes back to our knowledge with the knowledge we have with the functions, that the relationship between a function and its inverse is a reflection in the same line y equals x. And when you do a function, its inverse, the x and y values interchange. So a value that was, for example, a point that was, for example, 3, 2. When you reflect in line y equals x, it will go to 2, 3. And that's a quick way to do this transformation, right? So for example, this point up here now, which is the point 1, 6, is going to reflect down to 6, 1 right here. That's the easy way to do it. This point right here, which is 1, 3, 1, 3, is going to reflect down to 3, 1. See? 3, 1, 3, 1 right here. So this point is coming here, and this point is coming here. And then this point now, as we said, it's on the mirror line, and so it's an invariant point. This point I'm talking about now. It's on the mirror line, you know, and so it's an invariant point under the reflection. So it stays there. Another way of looking at it is that if you have a point 3, 3, which is this point right here that we're talking about, I reflect it, I interchange the 3 and the 3, it's going to remain 3, 3, so it stays where it is. So that's an invariant point under the reflection in the line y equals x. So let's look at the points now. So that point 1, 6 goes over to 6, 1. Then the point 3, 1 goes over to point 1, 3, sorry, goes over to 3, 1. And then the point 3, 3 stays where it is on the mirror line. So those are the 3 points now on the image after reflecting line y equals x. So having the advanced knowledge that if you reflect in line y equals x, all that happens is that the coordinates interchange. So the x and y values interchange on the point to get the image point. That advanced knowledge will help you to do reflection. And you're not trying to construct it. You're not trying to put any ruler or anything like that. That's the power of the knowledge, of the knowing stuff. Right? You draw the triangle now. Now that you have the points in place, you draw the triangle. And then it's almost label it R. Bam. Label it R. So we have now completed section 2. I have now completed section 2. Part 2. Part 3 says we have to describe now the single geometric transformation. This is how the must know come into play now. Look how the must know come into play now. Look at the power of the must know now. Describe the single geometric transformation which maps triangle P. This is the first triangle, you know. I'm gonna mark it. Triangle P onto triangle R. The
Rotation.
Oh, don't preempt. Don't preempt. Right? Triangle P, no problem. Triangle P onto triangle R. And let me tell you why I don't want it to preempt. I don't want it to go simple because it says a rotation and that's not enough. Whenever you're describing any transformation, you have to give the full description. You have to give the name and the components. Yes, it's a rotation, but if you just go in the exam and say it's a rotation, you get, if you question value 4 marks, you're getting 1 out of 4. You have to give the components of the rotation. So how do we know it's a rotation? Because what did we do to go from P to Q? Let's look back at it, and it's on the must know item as well, must know sheet. Reflected over this line first.
2 consecutive reflections.
Good. Don't preempt. Don't preempt. Don't preempt. Yes, 2 consecutive reflections over intersecting line, but don't preempt, please. I know that you know now this is beautiful. I like it. But please don't preempt. When I wanted to answer questions, I'll ask you. All right. So that's the y-axis. Then we reflected over the line y equals x. 2 consecutive reflections, as she said, which is correct. Now we have to look at the details now. The angle between these 2 lines, they intersect at the origin. So we know that the rotation center is at the origin. That's 1. Secondly, the direction is this way. We went from this to this and then to that. So we know that the direction is clockwise. The next thing now is what is the angle. Since the angle between these 2 lines here is 45 degrees, then we know that the rotation angle is 90 degrees. That's what we learned in the must know items. That 2 reflections over intersecting lines is equivalent to a rotation about the point of intersection of the 2 lines and twice the angle between the 2 lines. The angle of rotation is twice the angle between the 2 lines. And that's the power of knowing. But let's help out the students who don't know, who don't study the must know sheet. What do they have to do? So we never know. So knowing is the most powerful thing, you know. I can just write it down. Let me put it over here and show you. Bam, I can just write it down. P to Q is a 90-degree clockwise rotation about the origin. Oh, and what did I do? I gave the name of it, and I gave the 3 components: angle, direction, and center. Plenty people forget the center all the time. Let us not forget the center, please. Everything important. Let us not forget the center. All right, so suppose I didn't know that 2 reflections over intersecting lines are rotation, twice the angle between the lines. So you can just give the answer as quickly as we did. All right, and I see that the students getting sharp, which is beautiful. Right, beautiful. All right, what would you have to do? You have to do something like, for example, look at this horizontal. This short side is horizontal, and it is now vertical. So you know that it turned through 90 degrees. And this long side up here is vertical, but it is now horizontal. So if you just choose one, for example, this side, which is vertical, it has rotated and it is now horizontal. So you know that the angle is 90 degrees. I know that it turned this way, as it turned down. It's obvious that it turned down. All right. And then this one, well, let's look at the vertical alone. But the question is now, how do you know the center? The thing is that the center has to be such that the distance from the center to a point is equal to the distance to a corresponding point. And that's how we could know the center. But students wouldn't be clear, they wouldn't be 100% sure, especially if it's not on a graph paper. Right? That is why just knowing the stuff is much more useful. Knowing the thing that I tell you to know is much more useful. So you could still figure it out. That is a 90-degree rotation by observing that this side, which is vertical, is not horizontal. So it's a 90-degree turn clockwise. But then now you'd have to sort of measure to get the center. Right? And so you don't know that this distance, for example, is same as this distance. Let's say that this rotate 90 degrees. Right? And if you look at the third one, is distance up here from the center, and this distance up here, right? That's what you know. And another way to look at it is that the coordinates of this point, for example, is -1, 6. And you come down to this point here, which is now 6, 1. For all intent and purposes, these coordinates are going to give you the same distance from the origin as these coordinates, because they have the same values, the 1 and the 6. Have the same values. So in terms of distance from the origin, they will be the same distance from the origin. Let's look at another point. This point is -1, 3, and it rotates to this point here, which is 3, 1. Again, these coordinates, the 1 and the 3, will give you the same distance from the center. So that's how you could, from the origin, sorry, so that's how you could know it's a distance. If the rotation is about the origin. But why go through all of that if you can just know? Why go through all of that? We just know the must know item. All right, so that will be the answer right there for that one. So we have completed the third one. Beautiful. All right, so part 4 now, it says reflect Q now. Now remember, Q is the second one now. Reflect Q in the x-axis now and label it S. So we are now reflecting this one. I have to label it S and reflecting it in the x-axis. Same concept. Image distance equal object distance. Do it one point at a time. Don't try to reflect the entire triangle all at once. 1 point at a time. So see it there now? Bam. That's the first point I reflected. Let's look at it. This point is 1, 2, 3 to the mirror line. So it's going to go 1, 2, 3 on the other side. That's how we're getting that point right there. Let's go again. The next point up there is also 3. All right? Again, see it here? This point is 1, 2, 3 units to the x-axis, 1, 2, 3 units on the other side of the x-axis. And then we're doing this point up here now. It is 6. 1, 2, 3, 4, 5, 6 to the mirror line. It's going to go 1, 2, 3, 4, 5, 6 on the other side. It's coming to here. Do the reflection 1 point at a time. Don't try to reflect the entire triangle all at once. Pay attention to the details and the method to keep it safe. See there? Reflect that point again. Now that you have the 3 points in place, that is when you draw the triangle. And they say you must label it S. Label it S. All right, so look how CSEC wicked and testing. Well, not wicked. Look how CSEC good now and testing our knowledge of the must know items. So having completed that, the reflection over here, as part 4, and we label it S. Look what them ask us to do next now. Write down. In other words, what write down means you're supposed to know it. You're supposed to know it. Write down the matrix or the transformation which maps P to S. Write down, you know. Write it down. In other words, you don't need to calculate. No, you must just know what transformation taken from P to S. What did we do to go from P to S? We have a reflection over the y-axis, see there, to get to that. And then we have a reflection over the x-axis to get to that down there. That's what we did now. Let me clear it. That's what we do. Reflect over the y-axis to get to Q. And then we reflect over the x-axis. Reflect over the y-axis to get to Q. And reflect over the x-axis to get to S. So the same thing again. 2 consecutive reflections. And the angle between the y-axis and the x-axis is 90 degrees, and therefore to go from P to Q using the same thing, 2 consecutive reflections over intersecting lines is equivalent to a rotation about the point of intersection of the 2 lines. The x-axis and the y-axis, they intersect at the origin, so we know that the rotation about origin. The angle between the x-axis and the y-axis is 90 degrees, and therefore the rotation angle is 180 degrees. And we could say the direction is clockwise since we went from this to this and then this way. So direction is clockwise. So we could say it's a clockwise 180 degrees rotation about the origin. But we also know that a 180 degree rotation about a point is the same as reflecting through the point. Reflect through the point. So this point reflects through the origin to here. This one reflects through the origin to down there. And this one reflects through the origin to there. And that's what we could also say it's a reflection through the origin. So any one of those you put, they're gonna give you the mark. Because I feel like they'll prefer for you to say it's a 180 degrees clockwise rotation about the origin. But I'm certain that if you wrote a reflection through the origin, then they would still give you the marks. All right. But I'm showing you, and that I see you recognize what it is, but they don't want the description, you know. See, they want the matrix. And so you have to know what the matrix for that is. Right? The matrix for that is the one that comprises the y-axis reflection in it and the x-axis reflection in it. And therefore, you have to know your matrices. You have to know your matrices based on that question. See there? P to Q, what is it? It is a 180 degrees clockwise rotation about the origin O, or it's a reflection through the origin. And then see there, that's the matrix that they want. This is answer now. They wanted the matrix. That's what the question wanted. The matrix. Matrix, right? Down the 2 by 2 matrix. So if you give them the description alone, you're not getting any marks, you know. This is what they wanted. So you have to answer the question. So you have to know that that is a 180 degree rotation, and they know that the matrix is that. So that is why I'm telling you guys, learn those matrices. Learn those matrices. Look at the next part now. The testing and knowledge of the matrices again. Look at this part now. So we'll just finish now part 5. Look at part B now, B1. I want us to write those matrices again. Write them down. How are you going to write them down if you don't know them? You have to learn, you have to know them. So write down the matrices for reflection in the y-axis, which is the first thing that we did over here. It's the first thing that we did over here. First part up here was a reflection in the y-axis, which is what we did to go from this to this. All right? You have to know the matrices. All right, and then I want them to write down the reflection in line y equals x, which was the second one. All right, so let's look at it. So them here, B1 over here now. Reflection over the y-axis, I call it MOY, that matrix, -1, 0, 0, 1. The one with the first negative in it is the y-axis reflection matrix. Then one the y equals x reflection matrix. This is the one that looks like the identity matrix, but it is not. The ones are on the other diagonal. All right, the ones are on the other diagonal. So it's 0, 1, 1, 0. That's a y equals x reflection. And what did they say next now? Look at the last part now. So that's the answer for that for part B1, you know. Look at the last part, the testing and knowledge of the compound, the one transformation followed by another transformation again. We're supposed to know what the answer is before you even do it. Look at it. Using, they say using. In other words, you have to show the calculation now. Using the matrices from B1, in other words, using these 2 matrices that we just wrote down over here. Using these 2 matrices that we just wrote down over here. Right? What they want us to do. I have to show the calculation. Show the calculation. Using those 2 matrices, what they want us to do. Obtain a single matrix. Obtain a single matrix for the reflection in the y-axis, followed by the reflection line y equals x. Let me clear this up so we can see. I want a reflection in the y-axis, followed by a reflection in the line y equals x, which is what we did up here first. And we said it was a 90 degree clockwise rotation. So we know that when we finish doing this question, we're supposed to get the 90 degree clockwise rotation matrix, which has the -1 down here and the 1 up here. That's the answer. Say we know the answer that we're supposed to get. And what do we have to do? We have to multiply the second transformation matrix by the first one. So we have to multiply the second transformation matrix in front of the first one. We have to multiply the second one in front of the first one, and the answer is supposed to be the clockwise 90-degree rotation matrix. -1 up here, 1 up here, 0, 0. So you know the answer before you even do it. You know the answer before you even do it, because you know what you're supposed, you know what you're going to get. So all you have to do now is just show the calculation, right? Just show the calculation. But you know what the answer is going to be. See there, look. See there? Let's look at it. Part B2, our answer is second transformation multiplied by the first one. The y-axis reflection multiplied by the y equals x reflection multiplied by the y-axis reflection, right? The second matrix multiplied by the first matrix. Let me show you the calculation over here. See it here? Let me just show you the calculation. So let me just write it out. So it is my, not that one, my axis, or let's MOY. OY means y axis. All right, OY means y axis. MOY followed by my equals x, that means reflection line y equals x, is my equals x times MOY. They multiply them. The my equals x is 0, 1, 1, 0. I multiply that by the y equals x, the y-axis, which is -1, -1, 0, 0, 1. I multiply them in the normal way. And you know what the answer is going to be. Rows by columns. I know what the answer is going to be, but you can still work it out and prove it. Right over what the answer is going to be. The answer is going to be 0, 1, -1, 0, because that's a clockwise 90-degree rotation. That's what we're supposed to get. Let's work it out and show that that is the answer for real. Right? You know the answer before you even do it. Let's look at it. 4 values. 4 values. This value first. This row times this column. Look at it. Look at it. It's going to be 0 times this, 0, and this time this is 0. So it's the first value is coming out as 0. First value coming out as 0 right here, which is supposed to be 0. And this value right here now is this value right here. Let's this value right here now is this row times this column. So it's 0 times 0 and 1 times 1. So the answer there is 1. Obviously, the value there is 1. So you see, we're getting what we're supposed to get. And this value down here now, this value down here is this row times this column. See there, 1 times -1 and it's 0 times 0. That is -1. So you see the value down here is -1. Which is what you're supposed to get. And then the last value now, it is this row times this column. So it's 1 times 0 and 0 times 1. So that value right there is going to be a 0. Going to be a 0. This value is a 0. But you see, we get the right answer now. We know that that's going to be the right answer now. But they wanted you to show the calculation, because the question said using the matrices. See here? Using the 2 matrices in B1. So they want to ensure that you know which one to put in front of which one. You put the second transformation matrix in front of the first one. Second transformation multiplied by the first one. Because what they say is that you apply the second transformation to the first one. You apply the second transformation to the first transformation. All right? And that's how we do it. And so that is the answer. And that's the power of the must know sheet. You get the answer that you know you're supposed to get. But down here, I know that that is a clockwise 90-degree rotation matrix I'm supposed to get. And so the matrix for that one is that. And if you actually do the calculation, you get it. All right? So that is the first question. So I'm going to, but understand that so far? Very good?
Yes, sir.
Very good. All right, beautiful. So I'm going to give you 5 minutes. You think you need more than 5 minutes to do it? Or 10? What do you think you need? I'm going to pause the video now and give you 10 minutes to do it, or 5 minutes. What time is it now? All right, it's now, I'll give you 6 minutes. Let's look at the time up here. 11:44. I'm going to start back. I'm going to continue at 11:50. Come on, get going. 6 minutes to do it. Those of you did it. 6 minutes.
Sir, I found the questions in the book, you know, sir.
For the question, yeah, man, the questions in the book. But no matter I want you to actually do it. Questions are in the book as well.
Do
But
it
I
on the
pick these questions for the class activity. You can do it in the book. Once you have a surface to do it, no problem. But I want you to actually do the construction on the graph. That's the important thing.
Oh.
All right? All right.
Yes,
So get cracking. Do it. I'm going to pause the video and you do it. All right? All right. Okay, guys, stop working now. Moving on to the next question. All right. You can watch the video later. Watch the video later. So watch the video later to get back to what we're doing. All right. So let's move on to the second one. Let's move on to the second question. All right. So the second question is about enlargement. All right. I want to see the power now of the must know items with enlargement. So this is the second question we're looking at. Again, it's a past paper question from 2003. All right. So the question says, using a scale of 1 centimeter to represent 1 unit on both axes, but we have the graph already. We already have the graph, right? On both x and y axis, draw a graph, draw on graph paper, triangle PQR and P prime Q prime R prime, such that, and it gave us these points now. So basically putting down those points. So the first point is P. All right, let's put them on the graph over here. That is P. Careful, -3, -2. The next point is Q. Let's put on the graph over here as well. That's -2, -2. That's where Q is. Next point is R. -2, -4. Put on the graph over here again. Now that we have the points in place, draw the triangle. Draw the triangle. Put down the points and then you draw the triangle. Then we're going to the image points. P prime, 6, 4. Put down the point. 6, 4 is over there now. X and Y values are both positive. 6, 4. All right. And look at the scale properly, you know. Look at the scale on the graph properly. See? Let's skip out the 1. So like right here is 1. Right here is 3. Right here is 5. Therefore, right here must be 6. Right here is -1. Right here is -3. -3. Right here is 1. Right here is 3. Right here is 5. Right here is 7. Right here is 9. So look at those things carefully. Always with the scale of a graph carefully. Anyway, the next point we're doing is the point Q prime, 4, 4. Bam. 4, 4. Then we're doing R prime. R prime is 4, 8. 4, 8 is R prime. Don't do the question yet, pay attention. Don't do the question yet, pay attention. I give you a chance to do it. I want to kind of do it out of your head by yourself. Don't do it while I'm doing it. I want still for you to do it out of your head. That's the second triangle. Bam. That's the second triangle. All right, watch this now, students. Everybody pay attention. Before we even do anything, looking at these two diagrams, we can decipher some things without doing anything at all as yet, such that once you start asking questions, we know exactly what the answers are before we even do the questions. Firstly, we see that there's a change in size, because we see there's a change in size, obviously. This one is smaller than that one. Secondly, this one is the image, and this one is the object. Oh, I know that this one is the image and that one is the object. Because this one has the prime on the points. The prime on the points. So that's the image, that's the object. Clearly, the image is larger, so we know that the scale factor is greater than 1 or greater than 0. Well, not just greater than 0, greater than 1. Greater than 1. It's not a fraction. The scale factor is greater than 1. All right? In terms of value, the value of the scale factor is greater than 1. So it can't be that the scale factor is like a value, like a half or a third. It must be a value greater than 1. Value. The next thing we look, the points are in the opposite direction. So look at it. On this one, the R is pointing down, but the R prime is pointing up. The P is pointing to the left. The P prime is pointing to the right. But I can't see that. So they are pointing in opposite direction. The points are in the opposite direction. So we know right away that the scale factor is negative. So we know that the K is negative. So a negative scale factor. Then what is the value? The value of the scale factor is very easy to see. Look at it. Compare the corresponding sides. Look at it. I'm sure you can know this thing without doing any work, you know, by observation and just knowing certain basic things. Look at it. This PQ side is 1 unit on the object, but P prime, Q prime on the image is now 2 units. So that's a doubling. So it means that the value of the scale factor is actually 2, but it's negative. And therefore, you know the right away that scale factor is actually negative 2. Negative because the image and the object pointing in the opposite direction, and clearly the sizes are doubled. Look at this vertical side. The vertical side here is 2 units. The vertical side up here is now 4 units. Doubled. So the size doubled and the pointing in opposite direction, and therefore negative. So right away, before doing anything, we know the scale factor already is negative 2, and we don't do anything yet. The only thing we'll have to do now is find the center. Because remember, we know it's an enlargement with a scale factor of negative 2 already, you know. We know that already, you know. It's an enlargement with a scale factor negative 2. So the only thing we don't know yet is the center, and the center is the easiest thing to find, because all you have to do is join the corresponding points. We also know that the center is going to be somewhere between them. The center is going to be somewhere in between them, somewhere between them. That's where the center is going to be, somewhere between them. Because when the scale factor is negative, the center of the enlargement will be between them. Both of them will be on opposite side of the center. So if you give a center somewhere down here, so you know there's something wrong. If you give a center somewhere up there, so you know there's something wrong. All right. Well, let's go through the question now, though. Let's go through the question. So we already know that the scale factor is negative 2. Right? Without doing anything, we know by just looking, we know the scale factor is negative 2. But look what the question says. Question says, describe fully. Don't tell what it is, you know. Don't tell which transformation it is, you know. But it tells you to describe fully, and so to put the word fully in bold in cap letters. You know why? Because you have to give the name and the components. So you cannot, for example, just say it's an enlargement and done. You're not getting any marks. You have to give the name. And if it's an enlargement, you know, an enlargement has 2 components that you have to state both of them. You have to scale the scale factor, you have to state the scale factor and the center. We know it's an enlargement because it's a change in size. Once there's a change in size, you know it's an enlargement. Right? So describe the transformation G, which maps PQR onto P prime, Q prime, R prime. We know it's an enlargement. We already know the scale factor is negative 2. The only thing we need to tell them now is the center. So we have to locate the center by joining the corresponding points. So look at it over here now. See there, join P to P prime. And I join R to R prime. And you see that they intersect at the center. Kind of look a bit off, but it's really the center. The center is at the origin. Sorry, they intersect at the origin. So now that we know the center is the origin, I will know the scale factor is negative 2. I will know it's an enlargement, then we can describe it. We can describe it. You can describe it by listing, or you can describe it as a sentence. Just make sure that the name and the components are there in your description. So see it here? That's it over here now. Look at it over here now. G is such that triangle PQR maps onto triangle P prime, Q prime, R prime. The arrow there means maps onto. Colon means is such that. So transformation G is such that triangle PQR maps onto triangle P prime, Q prime, R prime by an enlargement. We cannot just stop and say it's an enlargement. You have to give the components. So I list them in this example. I could have also put them in a sentence. I could have said something like triangle PQR maps onto triangle P prime, Q prime, R prime by an enlargement of scale factor negative 2 about the origin 0, 0. Could have said that. But in this example, I list them. I give the name, which is an enlargement. and I give the two components. The scale factor is -2. If you put 2 alone, you're not getting the marks. You have to say it is -2. I will know it is negative because they are pointing in opposite direction. If you put a half, you're wrong, because we say from PQR to P prime, Q prime, R prime, it gets larger. So the scale factor has to be a value greater than 1 in value. And then because they're pointing in opposite direction, then you know it is negative because it is then inverted. It is inverted, right? Q to R was pointing down. It is now pointing up. Q prime, R prime is pointing up. So it is inverted. It is inverted over the origin. Origin is the center. Note also the distance. Look at it. We spoke about the distance. The distance from the center to here is doubled to there. Twice the distance. Twice as much. This distance is doubled up there. Doubled. Twice as much. Same with this one. This one down here is doubled. So remember, the scale factor also doubles the distance from the center because it is 2 and it is on the opposite direction. So this way is inverted now to that way and also doubled. All right. So everybody seeing that, seeing all of that. But that's in the description. So we basically have completed the first part. And if you never give the center, that the center is the origin, you're losing marks. And if you never put the negative on the scale factor, you're losing marks. And if you never put the scale factor at all, and never put the center, and all that you say that it was an enlargement, if the question value 4 marks, you're only getting 1. You're only getting 1. If the question value 4 marks, because it's obvious to everybody that it's an enlargement. You have to give the components, and that is why they put the word fully in cap letters. They put the word fully in cap letters. You have to give the name and the components if you're describing it fully. Even if they don't put the word fully, you still must have to always describe it fully. Everything important. So even if they don't put the word fully, you still have to describe it fully. Always just describe it fully. All right? Good. So we finished part 1. Part 2 now. Mute your mic, please. Mute your mic. Mute your mic. All right. Part 2 now says, transformation M is a reflection in line Y equals minus X. Bam, my brain start click already. Brain start click. I know that the matrix for that, if that comes into play, is 0, -1, -1, 0. What does that transformation do? It reverses the values and also change the sign. Remember, look, Y equals X matrix. We reflect in line Y equals X, right? A point, for example, that is AB will go on to BA. The values are interchanged. But when we reflect in the line Y equals minus X, remember the matrix for this one, is 0, 1, 1, 0. Right? Showing you the power of the must know items. When we go in the line Y equals minus X now, let me erase this and write it better. Mute your mic, please. Mute your mic. Mute your mic. When we do the Y equals minus X now, the more things you know, the better. The more things you know, the better. The matrix is 0, -1, -1, 0. What would happen to the point AB? A point AB would go on to switch them around and change the sign to become -B, -A. With this knowledge, you can do the thing faster. You don't have to be calculating and working on stuff. You can do it much quicker. That is why you must know what happens with these things. When you reflect in line Y equals X, the values switch around. I was supposed to know that from functions. With line Y equals minus X now, because of the minus, they switch around, but they also change sign. They switch around and change sign. So you can use that knowledge to do it. All right, let's look back at what the question wants us to do now. All right, so this one we know that a point AB, let's write it back up here. A point AB will map onto another transformation -B, -A. Right, use up your knowledge. It makes transformation question much easier. Must know items. Right? It says what I want us to do. They say on the diagram, draw and label P double prime, Q double prime, R double prime, the image of PQR. So we're going to reflect this one now over here. Look back over here. They want us to reflect this one in the line y equals minus x. You see, under transformation M. Transformation M is a reflection in line y equals minus x. So I will know what's going to happen. The value is going to switch around and change point. But we can also show some calculation for it, you know. So I'm doing it as if the student didn't know, but that the value switch around and change sign. But the more you know, the easier the question is to do. So let's look at it over here now. We're going to do that double prime triangle now. See it here. First, you have to do is put in the line y equals minus x. And just like when you draw the line y equals x, you have to put the points at the correct place. So for example, the line y equals minus x, it passes through points where the x and the y value are the same value but opposite signs. So for example, pass through point like minus 3, 3. And pass through points like minus 3, 3. Hold on a second. Hold on. Yes. Right. It pass through points like minus 3, 3, but pass through points like 4, minus 4. So it pass through points where the values are the same, but the x and the y values have opposite sign. One positive, one negative, right? So that's why I pass through a point like right here. Minus 2, 2. And minus 4, 4. And minus 6, 6. And then pass through a point like 2, negative 2. 4, negative 4, and so on. So you have to draw the line so that it passes through the correct points. Right? What I've seen over the years is some teacher just draw one line up so. Right? Let's go again. Some teachers just go like this. Do the right thing, everything important. Some teachers draw one line up so. Right? And say that is line y equals minus x. Even graph paper, they just draw one line up so. Don't do them foolishness there. Mathematics is most exact science. Draw it the right and proper way. Make it pass through the points that it's supposed to pass through. Don't do anything random. Do it exactly how it's supposed to be. Right? I'm telling you what I see people do in the past, and then students go and do the same foolishness. Draw the line the right way. Make it pass through the correct point. See it there. All right? Then you're going to reflect the points. Now remember, the values interchange and change sign, but you can also calculate it using the matrix. Let's look at it. Let's still using the matrix to calculate it. All right, let's look at it. And this is what I'm doing right here now. Right, I'm using the matrix to calculate it. So the matrix, you have to know the matrix to use it. See there? That's the matrix. So you still have to know something. That's the matrix. 0, negative 1, negative 1, 0. And I'm using 3 points all at once. So I'm putting down a big matrix for the 3 points. Remember, this is really 3 matrices in one. That's what this is. It's really 3 column matrices in one. So I put those red lines there because it's 3 column matrices in one. And then if you do the calculation, that's what's going to happen. So you see, look at it. These values, they switch around and change sign. These values, they switch around and change sign. And these values, they switch around and change sign. That's what happens when you reflect in line y equals minus x. The more things you know, the better. All right? The more things you know, the better. I'm not telling you to know stuff that you can't remember. So I give you the must know for you to study them. That's what happens with reflecting line y equals minus x. And so you can get the points easily. Right? See there? The point P prime. Look, let me write them down for you now. Can I always erase them afterwards. The point P prime. Let's look at it. Let me write it over here. Let me write it here. So the point P prime, which is 6, 4, is going to go down to P double prime minus 4 minus 6. The value switch around and change sign. See it on the diagram here? Minus 4 minus 6. Then the next point we're looking at is bam, Q prime. Q prime is 4, 4. That's going to go to Q double prime. Switch around and change sign. So you go to minus 4, minus 4. You can see it right down the graph. That's where Q double prime is. And then the point R prime, the next one. R prime, let's look at it. R prime, which is 4, 8. under the reflection line, y equals minus x is going to go to r double prime, which is now the value switch around, which is minus 8, minus 4. So it's going to minus 8, minus 4. So if you put them at the correct place, bam. See the r prime going down to minus 8, minus 4, and the reflecting line y equals x. Some people have to be trying to measure with rule and all them things. You don't want to do that. Use up the must know knowledge, use up what you know to do it. So if you don't know, say, let me switch around and change sign, then I'm showing that you could have calculated it, but you still have to know the matrix to do it. And then once you see what it does to one point, you know automatically it does the same thing to the other points. All right, I will do an example with that. And then you draw the triangle now. Bam, draw the triangle. So that's what they wanted us to do in this part up here now. That's what they wanted us to do up here. All right, so we have just completed this part here. Just completed part C, right here. Just completed that, which is to draw the triangle. So that's a triangle. They don't want to take us into some calculation now in part D. They want us to write down the matrix for G. Remember, G is enlargement, you know. G is the first one, you know. So G over here, so G is enlargement, you know. See it up here, so this is G, you know. Remember that is G. An enlargement of scale factor -2 about the origin. That is the K00 K matrix. And the K in this case is -2. So very easy. They want us to write down G. Bam. See there now? That's G. -2, 0, 0, 2. That's a K00 K matrix. But the K in this case is K in this case is -2. Hope you understand that. Then they want us in part 2 to write down the transformation M. Transformation M is a reflection in the line y equals minus x. We have it here already. See it here? That matrix. 0, -1, -1, 0. They want us to write it down. You have to know it in order to write it down. See there now? Bam. M is 0, -1, -1, 0. Look at the last part now. They want us to do the matrix. They want us to do the matrix. G followed by M. G followed by M is M times G. So to get that matrix, you have to multiply the M and the G, the M times the G, the second one times the first one. So to get the matrix, G followed by M, you have to multiply M times G. So multiply the M matrix times the G matrix and multiply them in the normal way. Bam, see there? G followed by M is M times G. So let me show you down here now what you have to do. Let me show you what you have to do now. See it here now? M times G. Let me show you right here. Let's write it out, but I can see it. G followed by M is, you want to get a single matrix. Both of them are 2 by 2 matrices, so you can multiply them and get a single matrix. Is the M times the G. So you just multiply the M matrix, which is 0, -1, -1, 0, by the G matrix, which is -2, 0, 0, -2. And multiply them the normal way. Rows by columns. Rows by columns. And your answer is going to be a big 2 by 2 matrix. Bam. 4 values. First value here is this row and this column multiplying. See there, the 0 times that is 0, and this time this is 0. So I know that that answer right there is a 0. And once I have a 0, they're going to get a 0 down there too. You know? Zeros are always on the same diagonal. But let's not assume, let's work it out. But that's what always happens. Then this value over here now is this row times this column. So watch it now. It is 0 times 0 and -1 times -2. -1 times -2 is +2. So that value here is +2. Then this value down here now, this value down here now is this row times this column. So look at it now. It is a -1 times the -2 and a 0 times the 0. The -1 times the -2 again is 2. 2 plus 0 is 2. Right? 2 plus 0 is 2. So down here is a 2 as well. And then the last value over here that we want now is this row and this column. So it is the -1 times the 0 and the 0 times the -2. That becomes 0. So you see, I know that the last value down there will always be a 0. The zeros are always on the same diagonal. So that's the answer. That's the MG. That's what they wanted for that last part of here. That's what they wanted here for this last part. MG, but you have to work it out and show them. Or you get it. Can't just look and know. That's it. See? On the M times G, I can write the answer now. Bam! See there? 0, 2, 2, 0. But understand that question?
Yes, sir.
But good?
Yes, sir.
All right, let me see the time now. It's now quarter past. I'm going to pause again and give you 5 minutes to finish it. Come on, remember, if you don't finish it in time, you can still finish it up after the class. But come on, 5 minutes to shut this one quick. Come on, let's go. I'm going to pause the video now. I'm going to pause it and you go. All right? All right. So that is that for that question. Always go back and watch the video. All right? Go back and watch the video, guys, so I can finish the question if we did not finish. All right, so let's move on to the next question. Let's move on to the next question. All right, so let's look at it here now. All right. Okay. All right, so next question here now is another example. Reflection question. And it's showing basically how they sometimes can use a column vector to represent the point. Column vector, the position vector of the point. But the column vector, which is the position vector of a point, will have the same coordinates of a point. So for example, in this question, they tell us of the position vector of the point H is that, so what that means is that the point H is actually negative 1, 1. This one is K, position vector of K is 1, 5. So it means that K is actually the point 1, 5. And then W is negative 3, 3. So it means that W is the point negative 3, 3. So sometimes they'll give you a point, but they give it to you in the position vector form. What they want us to do? They want us to reflect, so the vertices of triangle, these are the vertices of triangle HKW. And they want us to reflect it in the line y equals minus x. And then they want us to state the position vector of the image. They want us to state it. We can work it out, state it, because we know what reflection in this line does. We just did it a while ago. Reflecting line y equals minus x, the x and y values interchange and change sign. They interchange and change sign. But let's look at the approach over here. That's the matrix for it. I'm sure that you can actually use the matrix and calculate, but you can do a general point. See it here, a point xy will interchange and change sign. So xy will become negative y, negative x on the reflection line y equals minus x. All right, so that is it. So for example, the point H, which is negative 1, 1, will interchange and change sign. Let's look at it. The interchange first. Let's look at it. Or why that is the answer. So this, what happens is that the values interchange to become 1, negative 1 first, interchange them, and then change signs. So it becomes a negative, it becomes a positive. So you see you get back the same point. But another reason why I get back the same point is that this point, sorry about that. Right, another reason why I get back the same point, right, is that that point, negative 1, 1, is actually on the line y equals minus x. Negative 1, 1 is on the line y equals minus x. So if you reflect the line y equals minus x, it's coming back to the same point. And therefore, h and h prime is the same point. And a student asked me that the other day, if a point and its image can be the same point. And yes, because that's an invariant point under the reflection. If we look at the point K now, K, which is 1, 5, is going to go to negative 5, negative 1. The values switch around and change sign if you reflect in the line y equals minus x. And then the point negative 3, 3 is also a point on the line y equals minus x. So that point again is an invariant point. And so when you reflect in line y equals minus x, it's going to go back to the same point, negative 3, 3. Right? And so that point also is an invariant point that is on the mirror line y equals minus x. So let's need to draw it now, right? For the question part 2, that's part 1, and not to write down the position vectors. See, they wanted us to write down the position vector of the image point. That's what they wanted here. So I've just completed part 1 by writing down those position vectors. Right? These are the coordinates that they didn't give us, but they wanted us to write down the position vectors. So that is it. I've answered the first part. They wanted the position vectors. So they gave us position vectors here, and we are giving them back position vectors on the left side of the sheet there. All right. Then the second part now wants us to actually show it. It says use a scale of 2 centimeters to represent 1 unit on each axis. Draw the graph, draw on graph paper triangle, HKW and the image. So they want us to draw those two triangles, triangle HKW and H prime, K prime, double prime. So putting those points in. So see there, first one I have on here is H. See there, H, -1, 1. Next one is 1, 5. Look at the scale properly with this one, guys. A common mistake with this one for persons to put this as 5. That's not 5. Look at the scale properly. Every other line is 1. So every other line is 1. Every other line is 1. Skip a line 2. Skip a line 1. Skip a line 2. Skip a line 3. Skip a line 4. Oh man, this thing. All right, come again. Keep pressing the wrong thing. All right, come again. That's where we're at. All right, so putting in a point. So look, the point is that up here, you have to be careful. That's where 6. That's where 5 is. All the way up there, not here. Right there, so it's wrong. So some person would put it there, which is wrong. Look at the scale carefully. Every other line is 1. So that's where 5 is, right? All right, so if we continue, we're gonna put in the point W now. That's where W is. All right, and so that is a triangle. That is a triangle. And then now the reflected line y equals minus x. And as I said, the line y equals minus x will pass through the origin, 0, 0. Also pass through the H point and the W point. So that is the line y equals minus x. And then the H prime and the W would remain on the line when you reflect them in the line y equals minus x. So H prime is the same point. See it there? W prime is the same point. And then K now, which is 1, 5, is going down to -5, -1. Reflecting line y equals x. Look at it. -5, -1. Look at it. Going all the way down to -5, -1 there. I put in that point carefully. And then complete the triangle. And that is the image triangle. All right? That's the image triangle. So I've completed part 2 by drawing the triangle and its image. Then part 3 now, I've completed that part. Part 3 right here now wants us to name the axes, plural. Name the axis of symmetry of the shape made by the object and the image together. So what are the axes of this shape made by the image and the object together? The full shape. The full shape made by the image and the object together. It's actually gonna have 2 lines of symmetry, obviously. Let's put them in. So we're gonna have a line of symmetry right down the middle there between K and K prime. But also WH is a line of symmetry. WH right here is also a line of symmetry. Right? What's a line of symmetry? A line that divides the object into 2 halves, such that one half is the mirror image of the next. So that line is a line of symmetry for these 2 halves. And this is a line of symmetry for these 2 halves. All right, divides those 2 halves. So to give you those 2 halves. So that's it. So WH is a line of symmetry. And also KK prime is a line of symmetry. So that answers that one. But understand that?
Yes, sir.
Yes, sir.
All right, beautiful. So I've given you 5 minutes to do this one. So it's now 2:20, 2:28. I'm giving it until 2:23. Come on, get cracking. 2:23. I'm gonna pause the video over that time. Finish it up. 2:23 to just do that one quickly. Don't care if you finish. If you don't finish, you can always do it afterwards and you rewatch the video. All right. Go ahead, do it now. This one is supposed to finish this one quick. Starting back now, guys. Let's move to the next one now. All right. So remember, if you don't finish, no problem. You can finish it later when you watch back the video. All right. That's the beauty of the online class. Oh, I wanted us to do this question, right here. Even though it's a calculation, I wanted us to do that question. So let me set up so we can do it right here. All right, I remember after I do it, I need you to do the questions over again by yourself. All right, so let's look at this question. This question right here. Let's do that question right there. So the question says, the matrix N is described, the matrix N describes a transformation on triangle GDE, GDF. So this matrix is a transformation matrix. It's not one of our regular matrices, but it don't matter. You can give it any matrix until it's a transformation, right? And the same way, you multiply the transformation matrix by the points. All right, let's look what the question says. It is giving us the image points. It says the coordinates of the image are G prime is that, D prime is that, F prime is that. So they're giving us the image points. Remember, the object points are these, you know, but they are giving us the image points. First part says we have to find the matrix which would transform the G prime, the image, onto the object. So I want to go from the image to the object. And if this is the matrix that takes place on the original object, then I want us to tell them which matrix will take you now back from the image to the object. So I'm going to give a little schematic of what they're saying so you can see it. What they're saying is that triangle, I'll put it over here. What they're saying is that triangle GDF is mapped by transformation matrix N, which is 1, 1, minus 1, minus 2, onto triangle G prime, D prime, F prime. And we know this, they gave us that. And now they were asking, we know this, you know, this is what we know. We don't know this. We don't know the object point, but they happen to give us the image points. And they're asking us now, what matrix will map us back from here to there? Unmute your mic and tell me. What matrix is going to map us back from the image back to the object? Somebody tell
The
me.
inverse of N.
Beautiful.
Sir,
Inverse
negative
of-
1.
The inverse of N. You have to calculate the inverse of N. If N takes you this way, then N to the minus 1 take you back. That's how it works, you know. So if you never know before, now you know. If a matrix do a transformation and you want to go back the other way, you have to use the inverse to go back the other way. Just like how if a function does something, if a function maps a point onto an image point, right? Then the inverse function will take you back the other way, take you back from the image back to the object point. It's the same thing in matrices, same thing in transformation. If a transformation matrix take you from an object to an image, then the inverse of that transformation matrix will take you from the image back to the object. All right, so this question is testing our knowledge of that. So here we need n to the minus 1. That's what we need, n to the minus 1. Or we calculate n to the minus 1. 1 over the determinant of n times the adjoint of n. Calculate it in the normal way. N to the minus 1. So the answer for part 1 we're doing it now. This is the answer for part 1. You know. We want n to the minus 1, the matrix that will take us back. So we'll do it now. 1 over the determinant. What's the determinant? This product minus this product. The leading diagonal product minus the following diagonal product. The first diagonal product, or the leading diagonal product is negative 1. Negative 2, sorry, negative 2. 1 times negative 1 is negative 2. But understand that? This times this.
Yes, sir.
Good. Minus the second product. Second diagonal product is 1 times negative 1. So you're subtracting negative 1. So you're subtracting negative 1. Don't leave out this negative 1, you know. Otherwise, you're dead. Plenty of people put this minus 2 minus 1, which is wrong. It is wrong. It's minus 1 minus a negative 1. Pay attention to the detail. But understand that's so far. But understand that's so far. Multiply by the adjoint now. See, our knowledge of matrices, we don't lose it. We have to use it. All right? You interchange the elements on the leading diagonal now for the adjoint. Interchange those two. So the -2 goes here, the 1 goes there. Leave these two where they are. Don't interchange them now. Leave them where them there. Change the sign. Don't interchange them. Sometimes when you leave them where they are and change the sign, it look as if you interchange them. That's why I'm stressing it this time. I don't want people to believe that I'm interchanging them. It's just that when I change the sign of them, I'm going to get -1, 1. So it might look as if I interchange them. I did not interchange them. I left them where they are and I changed the sign. But I understand that. But I understand that?
Yes, sir. Yes.
Good. So sometimes
Yes,
depending
Dad.
on the value, good. Sometimes when you're depending on the values, when you leave them where they are and change the sign, it look as if you're interchanging. And sometimes some of the values, when you interchange them, it look as if it's change the sign. So remember, you interchange these two, leave these two where they are and change the sign. So pay attention to the details. And then what does it work out to? This is really a +1, don't it? So this under here, let me write it in red, what you really have under here. What you really have under here is -2 + 1, don't it? Which works out to -1, don't it? -1. Which works out to be -1, which is equal to -1, right? So under here is really -1. So it means that you can basically change all those values. Okay, divide each of those values by -1. So the final n to the -1 matrix that I want is 2, 1, -1, -1. That's the n to the -1 matrix. N to the -1 matrix. That's the answer for part 1. But understand that? So this right here is the answer. This is the matrix that will take you back. This is the answer. But good?
Yes, sir.
Yes, sir.
Yes, sir.
All right. Beautiful,
sir.
beautiful, beautiful. Then the second part now is telling us to calculate D, G, D, and F, calculate the coordinates. Coordinates. Remember, I know, they gave us the coordinates of the image, right here, I know they want us to calculate the coordinates of the objects. They want us to go the opposite direction. What do we have to do? What do we have to do? We know these points. Look, we know these points. And we try to get these points. And we know that this matrix that we just calculate down here. This matrix to take us from these points to these points. How do we do it? Nobody can tell me what we have to do?
So you have a times them?
So
Good.
I go calculate the matrix by the coordinate of the image.
Beautiful, beautiful. You couldn't say it any better. Couldn't say it any better. Multiply by the coordinates of the image, but you have to put them in the column vector form. Let me set it up for you now. Watch this now. So essentially, the n to the, let me show what is that mean. Let me show what is that mean. I'm going to give it a breakdown. Essentially, what is that mean is that n, the n matrix times the matrix for G, D, F. Oh Lord, let's go back. I think I keep pressing around thing. All right, give me a second, guys. I pressed the wrong thing. Oh, I don't know what to do. Press that. This is supposed to float. All right, good. I could bear me with technology, sometimes. I'm not as savvy as you guys. All right, so I'm saying the n times the GDF, triangle GDF, is equal to triangle G prime, D prime, F prime. All right, that's what is happening, Therefore, so we can say that implies that the n to the -1 times this is equal to this. So that's what we're going to do the calculation. So we can say, therefore, n to the -1 matrix times the image, as he said, G prime, D prime, F prime, is going to give us by the object, G, D, F, G, D, F. All right, that's what happens. And so in order to find GDF, we have to multiply that. We have to do the multiplication here. That's what we have to do. All right, that's what he said. So the G prime, D prime, the n to the minus 1, sorry. We're doing this now, we're doing this under here now. So the n to the minus 1, we just worked it out a while ago. See it here? 2, 1, negative 1, negative 1. 2, 1, negative 1, negative 1. Multiply that by the G prime, D prime, F prime. So they gave us them over here, so. So them over here, so. So the G prime is 3, 2. That's a G prime. G prime. And the D prime is 5, 2. That's a D prime. And the F prime is 4, 3. And that's a F prime. Putting all of them in 1. Equals. And we're going to work them out right here and just write them down. All right, not a lot, not difficult. So we're doing these 3 values. I want to get 3 values in here as well. Okay, let's work them out. It's not difficult. So that's how we're going to get our G, our D, and our F. I'm going to put the values in here and in here and in here. Watch it now. Let's watch it now. So the first value here is this row times the 1 column. So it's going to be 2 times 3 and 1 times 2. 2 times 3 and 1 times 2. That is 6 and 2 is 8. So this value right here is 8. Do you understand that?
Yes, sir.
Understand that? Good.
No, sir, I'm gonna get that bit over.
All right, let's go again. Remember, we're doing the first point now. We're doing the first one. We're doing the first one. Look, we're doing the first one. We're doing the G right there. So to do the G, we're going to use this times this to get this value on the G, and then this times the same thing to get this value on the G. Understand?
Yes, sir.
Understand that? Good. So just think of it as we multiplying a 2 by 2 by a column matrix to get a column matrix. So look at it that way. Understand? That's what we're really doing. Just like we're doing 3 column matrices in one matrix. So instead of doing this times this, and then doing this times this, and then doing this times this 3 times, we just use this times the 3 of them in one. That's how we're doing. All right. So let's go again. The first value that we want here, first value here is this row times this column. So it's a 2 times the 3 and the 1 times the 2. That works out to be 8. So the value up here so is 8. That is 8. Right? So we can take this out now. Then the second value now, the second value that we want right here. Second value for here is this row times the column. So it becomes -3 and -2. I'm gonna get that. The -1 times the 3 is -3, and the -1 times the 2 is -2. Understand that? That's -5. So this value right here is -5. -5. So far, so good?
Yes, sir.
All
Yes,
right,
sir.
good. So we're doing the next one now. So we're doing the same matrix. We're doing this column. We're doing this column now. We're doing this column now to get here. All right, let's go again. So this value first up here is this row times the column. So it's 2 times the 5 and the 1 times the 2. That's 10 and 2 is 12. So it means that the value inside this is 12. Right? 12. And then now, the second value down here, the second value down here now is this row times this column. So it's -5 and -2. See there, -1 times 5 and -1 times 2. That's how we get. Right? So that becomes -7. So the value right here is -7. -7. All right. So we're doing the next one now. The next point now. Pay attention. So now we're doing this point. We're doing the matrix times this equals these values now. All right. Let's go. So the first value up here is this row times the column. So it's 2 times the 4 plus 1 times the 3. This is 8 and 3 is 11, right? 8 and 3 is 11. So that is 11. So the value right here then is 11. And then the other one now. The other one now down here down here now is this row and this column. That is -4 and -3. That's -7 again. So it means that the value down here is -7. Let's try it better. -7. But the question asks for coordinate. You can't leave those are the answers, you know. I'll give them by them one. Look what the question say. Question say they want coordinates. These are coordinates. That's why you write coordinates. You put the point and then you put the bracket. So if you just leave this as the answer right here, you're not getting all the marks. Can never give the coordinates. These are position vectors that you have given them. So based on that, you can write, therefore, G is the point 8, -5. D is the point 12, -7. And F is a point 11, -7. Understand that?
Yes, sir.
Yes, sir.
Yes, sir.
Beautiful. So you have to work it out and you have to put them in the brackets to give them as coordinates, which is the answer. All right. So do this calculation for me
Sure.
now. Yeah.
Sir, so like how you like how you separate them a while ago, either way wouldn't it still represent what GD and F is?
What do you mean?
As in like
Wait a
where you
minute.
have G and you have 8
Here?
and you have, wouldn't it both still represent GD and F either way you put it?
You mean if I give it to them like this? Like
Yes,
over
sir.
here?
Yes,
No.
sir.
No, I know they represent GD, but you have to answer the question. Question keyword in the question is coordinates. Coordinates. When you write them like this, 8, -5, that's called position vector. That's position vector. Good question. I like question like these. So we can emphasize the details. This is called the position vectors of the points. Position vectors. Look what the question says. It's a coordinates are. So you see coordinates are written. Let's look at the previous question. The previous question gave us some position vector. Look at this one. It says the position vector of H is that. See how position vector written? Position vector is written like that as a column vector and that and that. That's the difference. Coordinates is written like these. So if the question asks for coordinates, you have to give it to them like how these are given to you. So you can't leave this as the answer. Over here, you can't leave this as the answer, even though it have the same values. You have to answer what the question says. If the question asks for position vector, so what the question is say, find the position vector. So I'm right there for you. These are the answers, you know. These are the answers, you know, because they ask us for coordinates. Coordinates. That's why you write coordinates. The difference. If the question is asks for position vectors, if keep doing foolishness, man. All right, let me just work it out just so. If they said, if we wanted, let's write it out, position vectors, which we're going to learn vectors as our next topic. You would have to write, OG is 8, -5. That's how you really write it, you know. OD with the arrow on top because a vector is 12, -7. And OF is 11, -7. Or if you want, you could just write these if they wanted the 3 position vectors. But that's a proper way to write a position vector, which we're going to learn in the next topic. So once I wanted position vectors, you have to give them it in the vertical format as column vectors like that. That's how position vectors are written. Understand? But coordinates are always written like this. All right, to make it stick. So you always have to use column vectors to do the calculation, you know. I said that in Transformation, we said that in the first class, because we say we have to follow the rules of what is possible. Remember, you know, you're multiplying at 2 by 2. If you put the coordinates and you have the values here and here, if multiplication is not possible, if you multiply at 2 by 2, this will be a 2 by 2 times a 1 by 2. If you did it this way, the number of columns here don't match the number of rows there. So this is not possible. If you do it that way, that is why you have to use a column vector to do it. So use a column vector or the position vector of the point to do it. So the point has coordinates 1, 6. You put the 1, 6 right here so for the calculation. But you know that this is the x value from here, this is the y value from there. You understand? And if you do the calculation, and so you do the calculation, you get back, and your answer is, so when you do the calculation, and your answer work out to be 39, for example. You know that the point or the coordinates of the point is 39. So you put this point in the calculation and get this point out back of the calculation. That's how it works. For the calculation, for the purpose of the calculation and transformation, you have to use column vectors because you have to set it up so that the calculation is possible. It's not possible to do it that way. All right, when you set up a column vector, it is possible. All right, enough on that because it's something that we explained before. All right, so we emphasize the point, the coordinates. So we have to give them it like this, coordinates. That's all right, I have to write it like that. That answers the question, boss?
Yes, sir.
Beautiful, beautiful. All right. All right, so the next thing we're gonna look at, so all right, so I'm giving you 5 minutes to do it. Come, it's now 12:55, I'll give it till 1 o'clock to finish it. This question that we just did over here. So I'm just gonna leave the question on the page. All right, I just did that question a while ago. Come on, give you 5 minutes to do it. If you don't get it fully, no problem. Remember, you're gonna go and do the and watch about the video and do it over by yourself. So come on, do it now. Do it. 5 minutes. Start doing it.
Sir, just but the points are must write out the working out.
Do the calculation, man. Do the calculation, man. Do the part 1 and the part 2. No, you're not drawing anything. This is a calculation one. There's not no drawing nothing. This one is a straight calculation. Everything in this one is calculation. If someone must calculate the matrix.
So just write it in our books.
Yeah, man, just write it in the books. 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 The solution for this one, as if you're working out a question. Let's do it quickly. Do it quickly. Then we're gonna come to this. All right. And pause the video. We'll pause the video, and then we come back to you. All right. Let's pause it. All right. Let's continue, guys. All right. So moving on to the next question. You can always finish that one. I said after the class when you watch the videos again. All right. So we're gonna look at another question now. I think the first part of this question is one that I have to do some calculation. That's why I marked it there. So I'm gonna slide this over. All right, this question is one where the first part of it right here, I have to do some calculation. So that's a calculation question. So pay attention. All right, so practicing still. I'm gonna do it on here. All right. All right, so ready now. Body back with us. Body good?
Yes, sir.
All right, beautiful. All right, so let's go. All right. So this question says, write down the matrix MY that represents a reflection in the y-axis. All right. Reflection in the y-axis. So part A, y-axis reflection matrix, and they call it MY. The one with the first negative one in it. First one I remember all the time. There's a negative one right there. Y-axis reflection matrix. One down here, 0, 0 there. That's a y-axis reflection matrix. That's part 1. Part 2, I want us to write down there. RL represents a rotation 180 degrees about the origin. All right, that's RL. Call it RL. I don't know what to call it, RL. But it's a 180 degree rotation matrix about the origin. Remember, this is the one that has a y-axis reflection and x-axis reflection in it. So it has a negative one up here. The x-axis reflection is down here, 0, 0. These two, one followed by the next, is going to be equal to the x-axis reflection, which is 1, 0, 0, negative 1. Both of them, one followed by the next, is going to be equal to this. I'm going to know my answer already. That's what I'm going to ask me. See it? Look what them say. Determine the single matrix. Look at it. Determine the single matrix U represent MY followed by RL. I know the answer already is this, because two reflections go with one rotation. So if I have a y-axis reflection, which is what this is, I have a 180-degree rotation, which is what this is. Both of them must give me, both of them, one followed by the next one, must give me another reflection, which is at 90 degrees to that, which is the x-axis reflection. And x-axis reflection is 1, 0, 0, negative 1. So I know my answer already is this before we even start doing anything. The answer is that. But let's show it. Let's show that the answer is that. Let's prove it. So you can know the answer before you even do it. All right, see it here. Bam. Let's look at it. That's part one and to write down those two. Part B. They say, right? They say determine the single matrix U, MY followed by RL. So they say U is MY followed by RL. That is, the U is equal to the second one times the first one, because MY followed by RL is RL MY. That's what the U is, you know. U is RL MY. Them choose to call it U. So I call it U too. But M followed by R is RL. M followed by R. M followed by R is RM. M followed by R is RM. So multiplying the R1 by the M1, and I know the answer is already. I don't even do it yet, but I know that the answer is the x-axis reflection, right? Because it is -1, 0, 0, -1 times the y-axis reflection is -1, 0, 0, 1. When I multiply these two guys, I'm going to get the x-axis reflection matrix. If you want to work it out and see it, no problem. Rows by the columns. Look at it. First value is this row times this column. See there? -1 times -1 is +1. So the first value there is a +1. Right here. +1. And then this value over here now is this row times this column. See? -1 times 0 and 0 times 1. That is 0. So that value is 0. Right here is 0. And only going to be 0 as well. The zeros are always on the same diagonal. Right? So, but this value down here now that we want is this row and this column. See there? 0 times -1 and -1 times 0. So that proves it. That value is 0. This value is 0. And this value down here now going to be -1. Oh, I know. Because it's the x-axis reflection. It is this row times this column. 0 times 0 is 0. -1 times 1 is -1. So you see, that's the beauty of the must know. The answer is -1 and no. The answer already. That's x-axis reflection matrix. Study your must know sheet and you'll know the answer before you do it, as I do. All right, so that finishes that part. Part C now. Part C. You just have to show calculation, you know, because the question said determine. Determine. So you have to actually show some calculation to show it. But you know the answer before you do it. Describe this. See there? The -1 is up here. That's an anti-clockwise 90-degree rotation matrix. And the -1 is up here. All right. Determine the single matrix RP. So see it here? RP. RP. We're doing part B1 now. B1. No, C. C part 1. C part 1. They give us RP. I don't know why they call it RP. They call it them one call it 0, -1, 1, 0. Oh, I remember that one. Because if I rotate up the side here, the -1 is up here where the arrowhead is. So that arrow telling me where the negative is. I know that that's a 90 degrees clockwise up that way. That's anti-clockwise. No. So that's an anti-clockwise 90-degree rotation matrix about the origin. And so I must describe it in words. Let me write it. All right. So RP is represents an anti-clockwise. So it's a counterclockwise. Anti-clockwise. Anti-clockwise 90-degree rotation. Don't forget the center now, which is origin, about the origin. Everyone can write 0, 0. What have we given for the description? We'll give the name and the components: angle, direction, center. You give the name and the 3 components. Rotation has 3 components: angle, direction, and center. Some people list them, some people write them out in a statement, a sentence. Sometimes I will list them, sometimes I will write them out in a sentence. It don't matter. Just make sure that whatever you give the examiner for the answer, it has the name and it has the 3 components. So RP is an anti-clockwise 90 rotation about the origin. Anyway you want to write it. The next one, all the matrices for reflection and rotation have 1s in them. So this one I'm giving right here, so now I have 2 and 2 right there, so that's a K and a K. That's my enlargement matrix right there. So that's an enlargement of scale factor 2 about the origin. Again, you have to give the name and the components. And since it's enlargement has 2 components. It has a center and a scale factor. That to state both of them. So see it here now, E, which is 2002, is an enlargement of scale factor 2. If you want to say K equals 2, if you want to both up and say scale factor, K equals 2 about the origin. When the center is the origin, you can say about the origin. If you want to say with center at the origin or something like that, or with the origin at the center, anything like that. Origin. CSEC will want to give you the marks, you know, so anything you write to make sense and it is correct, they'll give you. However you want to put it. As I said, some persons will list it. They'll say E is an enlargement. Let me say scale factor equal to origin, center. Center, origin. Center is the origin. Something like that. The center of the enlargement is the origin. Origin is remember, the origin is right here now. Origin is right here now. Where the y-axis and the x-axis meet. That's what I mean by the origin. In case I don't know, I'm taking for granted that you know, but that's it. So that is it. All right, beautiful. That's the description. So I finished part A, B, and C. Now part D now we have to do on the graph. So pay attention now. Part D now we have to do on the graph. So this is an enlargement question now. What is question now? Part D now. Part D says, using the axis, that's this axis that I have over here now. We must draw the pentagon ABC, ABCDE with vertices. They give us the vertices A, B, C, D, and E. So we're going to draw all of them. All right. So let's see it over here now. There, that is the point A. A is 1, 2, right there. Then B is 4, 2. So let's draw that one as well. B is 4, 2. See there? B is 4, 2. Then C is 4, 5. See there? Bam. C is 4, 5. Look at the coordinates carefully. Then D is 2, 6. Bam. D right there is 2, 6. And then E is 1, 5. Bam. E is 1, 5. Put the points in. After you put the points in, then use your ruler and you complete it. That's a pentagon, 5 sides. All right, what do they want us to do with the pentagon now? First thing they want us to do, they said draw the image of the pentagon, A, B, C, D, E. All right, represent under transformations represented by RP. You know, remember RP is this one, you know, anti-clockwise 90-degree rotation, you know. And then they want the enlargement, E is that one. So they want us to do the rotation. They want us to do the rotation of the triangle. And they also want us to do the enlargement. Now, you can make it easy for yourself by just calculating, using the matrix to do the calculation. Use the matrix to do the calculation. But you don't have to calculate all of them. You just need to see what the matrix did to one point, and it will do the exact same thing to all the other points. Let's look at it over here. I'm going to use a calculation method to do it. So I'm going to say, okay, let's do observation. When the matrix is 0, -1, 1, 0, which is the anticlockwise 90-degree rotation matrix, and you apply it to a point xy, I'm doing a general point, apply it to a point xy, I'm going to do the calculation, it's going to go to this point. Because it's going to be 0 times this, and then -1 times y, that's how I get the -y. All right? And then for the other point, it's going to be the 1 times the x, and the 0 times the y, that's how I get the x down here. So I know that under that rotation, anticlockwise 90 degrees, a point xy will go to -y x. What that means? The x value comes down here and stays the same. The y value goes up there and change sign. So it's like they switch around, but the value that comes in front change sign. Any way you want to look at it. All right? The y value goes to the front, and the y value becomes the x value, but change sign, and then the x value becomes the y value. And you just need to do that with all the points. Look at it now. That's what that means. Under that rotation, a point xy will go to -yx. So the y value goes to the front and change sign. Look, pay attention to the details because you're going to do this to all the points now. The second value go to the front and change sign. The first value go to the back and just stay as it is. So the x value becomes the y value over there. But then the y value becomes -x. Change becomes the x value with a different sign. Hope everybody understands that. All right, so you're going to do that same thing to all the points now. Jeez, all right, let's go again. Keep pressing around thing. Let's continue. Go back to all right. See there? Bam. So like the point 1, 2. They switch around, but the 2 becomes -2. But understand that? So that's where the point A is gonna go under the anti-clockwise 90-degree rotation. So you have to do like a calculation. Just observe what it does to a general point and do the exact same thing to all the points. Tell me if you don't understand that.
Yes, sir.
Good. So that's all you have to do. We're doing it the easy way, you know. We're doing it the easy way. So that's where the point A prime is. So I put it down here now. That's where A prime is gonna go. See it here? If we rotate anti-clockwise 90 degrees, see this point is rotated to hit this point anti-clockwise 90 degrees about the origin. That's where it's gonna go. But the calculation does it for you. Let's look at what happens to B now. See B going to that 4, 2, switch around, and the 2 become -2. So B prime point is -2, 4. So I just put down -2, 4 on the graph now. See there? -2, 4. But understand that? That's where the image of B is gonna go. When you rotate it anti-clockwise 90 degrees about the origin, the calculation is telling you where it's gonna go. We're doing it the easy way. You don't have to calculate all of them. Just look and see how it put to one point and to all the points the same way. Same way how the transformation affects one point, it affects all points the same way. I have to do your transformation one point at a time. Don't try to rotate the entire pentagon all at once. If you try to rotate the entire pentagon, you're going to draw foolishness. Do it one point at a time. Let's look at the C now. The C, which is 4, 5, under the anti-clockwise 90-degree rotation, will go to -5, 4. Let's break it down again and show you. So you see the x value going to become the y value. And the y value come to become the x value, but the change sign and become negative. That's what happens. That's what happens. And you do the same thing to all the points. So C is now, the C prime is now point -5, 4. Put it on the graph. Put it on the graph. -5, 4. See there? -5, 4 is that point right there. They will do the same thing to D. D, which is 2, 6, becomes -6, 2. When you rotate it anti-clockwise 90 degrees about the origin, it goes to -6, 2. So just put on the point -6, 2 right there. And then the last point is E. E was the point 1, 5. So you do the same transformation to it. The 1, which is the x value, becomes a y value, and the 5 becomes -5. The y value of 5 becomes an x value of -5. So the image point under an anti-clockwise 90-degree rotation about the origin is -5,1. So you put on the point -5,1 and you mark it E prime. That's it. Now that you have all 5 points in place, then you use a ruler and you join the points to form the image pentagon. That's the pentagon. If you rotate 90 degrees anti-clockwise about the origin, that's it. Do it the easy way. Don't try to construct it when you have the matrix to use. Just see what the matrix does to one point and you do all the other points the same way and get it quickly like that. You do the mathematics the easy way. Mute your mic, please. Mute your mic. Mute your mic. All right. That's it. We're going to do the enlargement now about the origin. Remember, I told you that the enlargement easy. If the scale factor is 2, you just basically multiply the coordinates by 2. If the scale factor is 5, you multiply the coordinates by 5. If the scale factor is -2, you multiply the values by -2. That is all. You multiply the coordinates by the scale factor when you have an enlargement about the origin. So since the enlargement transformation over here that we're looking at, this one, that's what I'm going to do next, This one is a scale factor of 2. It means that you just multiply each of these coordinates by 2 to get the image points. That's all we have to do. Easy. Do it the easy way. Don't try to construct it. Do the one point at a time, and when you have the image points, then you draw the final figure. Don't try to do the entire diagram all at once. You'll write foolishness. Let's look at it. See there? I'm telling you what the E does now. And the enlargement of scale factor 2, where the matrix is 2, 0, 0, 2. If you apply it to a point xy, that point will go to 2x, 2y, meaning that the coordinates are doubled by the scale factor. See there? A point xy will go to 2x, 2y. So for example, the point A, which is 1, 2, will go to 2, 4. The 1 is doubled to 2, and the 2 is doubled to 4. But understand that? And that is the A double prime. Good. And you put on the point A double prime. Bam. A double prime is right there. 2, 4. Don't matter that it is in the middle of the image of the object. That's where it is. Remember, it is the original pentagon that we're enlarging. The original pentagon. We're going to double it. So in addition to being double, the distance away from the origin is double. Look here. This distance is doubled to here. That distance is doubled from the origin because the origin is the center. So all the points will be doubled out as well. The distance from the center is also doubled. That's what a scale factor of 2 does. Double the size and also double the distance from the origin. The mathematics make it work for you. When you apply the matrix 2, 0, 0, 2 to the point, the coordinates are doubled because of the 2. If it was 3, the coordinates will be tripled. If it was -2, they'll be doubled, but they also become negative. So it will go on the opposite side of the origin. Let's continue. So the B now. The B, let's look at it one at a time. Look over here. One at a time. Look. We're doing the E now. Applying the E to these points now. So this point, which is 4, 2, is going to double to 8, 4. 8, 4. So B is going to 8, 4 under the enlargement. B is going to 8, 4 under the enlargement. Pay attention over here now. That's where B is, 8, 4. But I can see it, 8, 4. But I can see that.
Yes, sir.
Hello. Good. They were doing C
No,
next.
sir,
See
I don't
there?
see it.
See upon the diagram, no man. That's what I'm asking. See it? See there? B gone out of 8, 4. This point under the enlargement from here doubled out to there. So doubled.
Oh,
The
we see it
distance
now,
is
sir.
doubled. Good, beautiful. So I'm showing the points over on the left side, but I'm doing the construction on the graph. Showing where the points will go. So that is B. Look at C now. C is 4, 5. It's going to double out to 8, 10. It's going out to 8, 10 under the enlargement of scale factor 2. Look at it. 8, 10. Look at the diagram. You see it? That's where C double prime is. Look, it's doubled. The distance from the origin is doubled. See here? This is doubled out to there now. Doubled. The distance is doubled from the origin because of the scale factor. That's where C double prime is under the enlargement. Look at the point D now. D is 2, 6. 2, 6 is double to 4, 12. Going to 4, 12. Look at it on the diagram now. Bam. 4, 12 is right there. That's where D will go. See here, look at it. From the origin, D is doubled. The distance from the origin is double because scale factor is 2. See here, D. It is now doubled up there. The distance from the origin is doubled, twice the distance, doubled. All right? That's where D double prime is, the image. And the last one now is E. E is 1, 5. Under enlargement of scale factor 2 about the origin, that point E is going to go to 210. 210. Put on the diagram. See there, 210. So those double prime points are the image under the enlargement of scale factor 2 about the origin. Bam, you join them. And get the image triangle. That's the image of the enlargement right there. But understand that?
Yes, sir.
Yes, sir.
Beautiful.
Yes, sir.
All right, I'll give you 5 minutes to do it now. You don't have to do the calculation up here that we did. Because this calculation up here is very similar to all that. That's why I do the graph part. Little later, I want you to do the calculation part up here. Little later. Go over the calculation. Because remember, you're supposed to redo every question that we do in the class. Do the construction for me now. Do the enlargement. Remember what we did over here for the rotation? Use a general point and look what happens to a general point, and we apply it to all the points. And then the enlargement part, easy. I just double all the coordinates. Come on, I give you 5 minutes to do it. Give you 5 minutes. I'm gonna pause the video. I'm gonna give you 5 minutes to do it. Come on, you can do that. All right, it's now 1:24. I'm giving it until 1:29. 1:29. I'm gonna pause the video now. Let's move on to the next question now, guys. Remember, you can always come back and finish that later. And when you're watching over the video later, you have to redo. Remember to pause the video at stages like these. All right? You're redoing and correcting your answers. Pause the video. All right. Let's continue now to the next question. All right. So the rest of them kind of easy. All right. So you shouldn't have much problem. All right.
Sergeant.
All right.
Never mind.
All right. Yeah, man. Thanks for that, Kai. All right. So this one now. And they're gonna get easier now, all right? They're gonna get easier. This one now says, the diagram, draw an answer sheet, shows triangle ABC. It says T is a translation. T is a translation vector represented by a -6, 0. So T is a translation vector, -6, 0. So T equals -6, 0. And we must know what this means. This simply means 6 units to the left. That's what it means now. Remember, this value is a horizontal movement, but because it's negative, it means that they're going this way. 6 values to the left, 6 values in the negative x direction. You can look at it that way. All right? That's what it means. 6 units to the left. All right, what else I'm saying now? The R now is a 180-degree rotation about the 0.53. Now, since it's about the 0.53, we cannot go and use our matrix -1, 0, -1. You know? We can't use it because this matrix is for when the center of the rotation is the origin. So anybody, because them say 180-degree rotation, run to this matrix, gonna lose some marks. What the matrices that we have learned, a rotation is when the center of the rotation is the origin. So because we know rotating about a point that is not the origin in this question, which is right here, it means that we have to do it by construction. But the key thing to remember is that a 180-degree rotation about that point is the same as reflecting to the point, and that's on the must-know sheet. A 180-degree rotation about a point is the same as reflecting to the point. It's more difficult to do the rotation, the better you reflect to the point. So that's what this question is all about, guys. So the first part here wants us to write down the coordinates of the triangle, A, B, and C on the triangle here. Just writing down the coordinates, right? A. So clearly A is a point right here. It is 1, 6. B is a point 5, 6, and C is a point 5, 8. So this guy just writing down those coordinates. All right. See there, A is a point 1, 6. B is a point 5, 6. And C is a point 5, 8. That's the answer for the first part. Second part wants us to draw, see here, draw and label triangle A prime, B prime, C prime, which is the image of triangle ABC under T. So in other words, to go from triangle, to go to the prime triangle, you have to do the translation. Remember, the translation is 6 units to the left. Do your transformation, whichever transformation it is, do it 1 point at a time. Don't try to move the entire triangle left all at once. You're gonna write foolishness. Do it 1 point at a time to make sure. So all you have to do is move the vertices 1 point at a time. So A, I move it 6 units to the left. That's what the negative 6 means, 6 units to the left. 1, 2, 3, 4, 5, 6 coming to here. Move this one 6 units as well. 1, 2, 3, 4, 5, 6 coming to there. Move this one 6. 1, 2, 3, 4, 5, 6 coming to there. Then I draw my triangle. That's all you have to do. 1 point at a time. Just look at it. 1 point at a time. See, I move A. That's A prime. 6 units to the left. Then I move B. 6 units to the left to there. Just count it off. Then I move C. 6 units to the left. Don't try to move the entire triangle all at once. So much time I say that something there. So much time I say it. People try to do them transformation and try to draw the whole triangle one time. No, don't do that. 1 point at a time to make sure that everything is correct. Do the transformation. When you're constructing a transformation, do it 1 point at a time. Now that you have the 3 points in place, then you draw the triangle. Join the points now and draw the triangle to make sure it's right. That's a translation. Negative 6, 0. 6 units to the left. Good. The next part, that's part 2. The next part now is for us to draw the image triangle now, double prime. Draw and label triangle A double prime, B double prime, C double prime. See here now, the image of triangle ABC on the transformation R. Transformation R, remember, is this one. A 180-degree rotation about the point 5,3. But because the center of this 180-degree rotation is not the origin, we cannot use the rotation matrix that we know. The rotation matrix that we know, which is -1, 0, 0, -1, for 180 degrees rotation, is when the center of the rotation is the origin, 0, 0. So we cannot use that matrix. So this one we have to construct. There's no matrix that we know that we can use. So we have to actually do the construction. We'll do it by construction. So we have to put on the center point and actually do the rotation, but it's more difficult to try to do the rotation. So the important thing to know is that instead of trying to do a 180-degree rotation, we reflect through the point and use image distance equals object distance. Let me show you now. See here. Very important to know that a 180-degree rotation about a point is the same as a reflection through the point. Image distance to the point equals object distance from the point. Image distance from the point on one side equals image distance on the other side. Image distance on one side from the point equals object distance on the other side. I'm going right through the point. And I did that in the class the other day. Let's look at it. So the first thing you have to do is put on the point where you're going to reflect through. See there? 5, 3. That's the point you're going to reflect through, right here now. Put it on first. All right? 5, 3 is the point you're going to reflect through. And then you do it 1 point at a time. So let's look at the point A now. So it's like you're reflecting the point A through it. So that distance, you're going to carry it through it to that distance down here. But you want to make sure you say it right. So if you can't get this distance straight, if you can't get this distance directly, you can actually get the distance by counting how many units down and how many units across. So it is 1, 2, 3 down, 1, 2, 3, 4 across. So to get the same distance on this side now, you go 1, 2, 3 down, 1, 2, 3, 4 across. You see that it's coming here. That's where it's going. But understand that. And then the B easier now. Look, let's look now. The B easier because the B is 1, 2, 3. It's gonna go 1, 2, 3. So the B coming there. And then the C now is 1, 2, 3, 4, 5. Gonna reflect it and go 1, 2, 3, 4, 5. So the C going down there. Let's put everything together now. Watch this now. Bam. Reflect the A through the point. It go down to there. That's the A. It's a prime, or it should be double prime, guys. This should be double prime. So the A double prime. My mistake. Oh boy, I keep pressing the wrong thing. Let's go again. Let's go again and go back to where we are. So I'm saying this should be A double prime. Let's go. That's a point. Reflect it through. A little bit A, where it should be A double prime. So what I want to press is this. I don't know why I keep jumping off. So it should be A double prime. Right there. Double prime. A double prime. Then we're gonna do B now. Same thing again. Reflect B to the point. 3 units to the point, 3 units on the other side it going. And that's B double prime as well. B double prime, Christian said. So that's B double prime. That's where B double prime is. Then we're going now for C. C is 5 units, gonna go 5 on the other side. 5 units, you reflect it through. That's C double prime now. C double prime. Bam. C double prime. Again, do your transformation 1 point at a time. So instead of trying to do the 180 degrees rotation about the point, we reflect it through the point because it's easier. It's easier to reflect through the point than to try to say you're rotating. Right? So it's a good thing to know. And then once the points are in place, bam, you draw the triangle. But then I can show that we actually did a rotation. Look at it. It's almost like we did a rotation, but we never really rotate. We actually did a reflection through the point. Now tell me, do you all understand that?
Yes, sir.
Yes,
Yes,
sir.
Cool. All right, I'll give you 3 minutes to this one. This one's so easy, I'll give you 3 minutes. Don't need all of 5 minutes. So no, 140, gonna finish that 143. Come on, shut it up fast. All right, do it. And don't remember, don't matter if you get it right now, because you're gonna do it over later when you watch back the video. All right, so come on, 3 minutes to do it now. Let's go. 3 minutes to do it. Let's pause the video. All right, so that's it. So remember, if you don't finish, no problem. You can always, do it in your own time later. Watch back the video. Make sure you get the full understanding and do it properly. Everything important. Get the correct answer. All right, get the correct answer when you do it over later. All right, so we're looking at the next question now. Last question for the day. For today. All right, tomorrow we're going to practice a number of past paper questions. All right, this question down there, we did it already. All right, as I told you, we don't need to do this one. This one is a matrices question. That's a matrices, full matrices question. We did this question in the class the other day. All right, so that one covered already. In the previous class, we did that one. So we really only need to do this part right here now, and then we'll finish for today. All right, this part up here. All right. So the question says, on the graph paper, draw the x-axis and y-axis. So we actually did the part already. Use a scale of 1 centimeter to 1 unit. That's done already as well on both axes. And then we're to draw a triangle DEF. So this is what we're doing now. We're drawing triangle DEF with vertices 1, 1, 3, 1, and 1, 4. So we're drawing that triangle DEF. So let's put them on over here, 1 point at a time as usual. So sit here now, drawing that triangle. That's the point D, 1, 1. Then the point E is 3, 1. Then the point F is 1, 4. So those are the points. Draw the triangle. Beautiful. So we answer the first part right there. Part A is to draw the triangle. Next part says, draw the image of triangle DEF. So the image of that triangle on a reflection in the line x equals 4. Remember, x equals 4 is a vertical line. X equals a number line are vertical lines. Why? Because remember that the y-axis is the first vertical line. It is x equals 0. The y-axis is the first vertical line, x equals 0. The x-axis is the line y equals 0. Remember. So if you want a x equals 4 line as they do over here, it must be vertical like the y-axis and pass through 4. So the vertical line passing through 4. So they want us to reflect that triangle in the line x equals 4. So we need to show the line and then do the reflection again, 1 point at a time. Image distance equals object distance. All right, so that's the line x equals 4 right there. Same thing again, 1 point at a time. 1 point at a time. First point is D. But understand that D is 3 units to the mirror line. It's gonna go 3 units on the other side. That's D prime. E is 1 unit to the mirror line. It's gonna go 1 unit on the other side of the mirror line. See there, E. That's it. And then F is 1, 2, 3 units to the mirror line. It's gonna go 3 units on the other side of the mirror line. Bam. Do your transformation 1 point at a time. Don't try to reflect the entire triangle all at once. I'm certain I said that about 20 times today already. Don't try to draw the image triangle all at once. Do your transformation 1 point at a time. Transform 1 point at a time. And when you have the points, image points in place, then you use a ruler and you draw the image. That's it. To make sure so you get it right. Plenty times people do the wrong thing because they try to reflect the entire triangle all at once. They figure that they can figure it out in their brain and draw the image one time. Don't do that. Do the safe way, 1 point at a time. Image distance equals object distance. As easy as it is, people make a lot of mistake and write foolishness because they don't follow simple procedures. All right. So that is the image triangle and a reflection in the line x equals 4. So basically finish this part of it over here, part 1. Part 2 now, right here now, part 2. Part 2 says now draw the image of the image, draw the image of the prime triangle. So drawing the image of the prime triangle under translation 0, -5. What does 0, -5 mean? It means 0 units left or right. It means you don't go left or right. The -5 means that you're going 5 units down. So it means that we're moving each point 5 units down. And we're going to get another image now, which is a double prime. So the second transformation image we're going to get now is a double prime. So transforming each point 1 point at a time again, each point must move 5 units down. That's what this transformation will do. This translation transformation will move each point 5 units down. That's what the negative means. The 0 you say means that you don't go left nor right. 0 units left or right. And then the 5 here now means that it's 5 units, but the negative means 5 units down. 5 units downwards. So you're moving each point 5 units downwards. Simple thing. Let's go. First point is D. 5 units down to there. D double prime. 5 units down. Let's check it. 1, 2, 3, 4, 5. See it? 5 units down. Do the same thing with all the other points. E. 5 units down as well. See there? 5 units down to there. It's a translation we're doing. So moving triangle 5 units down, but don't try to move the entire triangle all at once. Same thing, 1 point at a time. Make sure you say it right. F. Move the F prime down 5 units to there. Know that you have the 3 points in place, then you draw the triangle. Don't move the entire triangle all at once. You'll draw foolishness. That's it. Know that that is it. That is the answer right there. That's the image triangle. Second image triangle, double prime. Watch this now. Next part, part 3 says, part 3 we're looking at now. This part. It says name it. Name the type of transformation that maps the first triangle to the last triangle. In other words, what type of transformation map this one to this one. And what did we do? We reflect over the line x equals 4. Then we did that translation. Glide reflection. Beautiful. How we know it's a glide reflection? It's a reflection in a line and a translation that is parallel to the mirror line. Remember, for it to be a glide reflection, the translation part of it, which was this down here, so has to be parallel to the mirror line, which it is parallel. So a reflection in a line and a translation that is parallel to the mirror line. Now remember, they could have done the translation first down here and then the reflection. The result will be the same, but beautiful. That's a glide reflection. So you see, I think I've touched all the various things that you're supposed to know in this question today. Let's look at the solution. See there, triangle DEF is mapped onto triangle D double prime, E double prime, F double prime by a glide reflection. And you give the components of it now, the components. Bam, it's a reflection line x equals 4 and a translation 0, -5. Those are the components of the translation. All right, so I'm now going to go on a break to do this one. I'm going to do this one when the class done. Because we'll finish up now, finish up now. But all the solutions are in your handout, for these as well, Look in the handout, the last part of your handout, all these diagrams that we have here are there. The calculation part's not there, but all these diagrams are there. So you also have that as a reference for your correction. So if for some reason the video not working or whatever, you still can use your handout. The last set of slides in your handout, those questions are there. Right? The answers are there. All these questions that we did today, they are there. The slides, the diagrams, everything, they are there. All right. So tomorrow, we're gonna pick it up back tomorrow. And what we're doing tomorrow, we're gonna practice some past paper questions tomorrow. As you know, that more maths equals better maths every time. Right? But before we jump off, I just want us to have a quick look at the must-know sheet to see if we covered everything today. Understand? I want us to have a quick look at the must-know sheet. The must-know sheet, critical, very important. I don't want to take it for granted. If you learn the must-know sheet, you'll be very preemptive. You can answer questions quick and fast. Know what the answer is going to be. Some of the persons used to preempting me today because I studied the must-know items and know it now. And I want you to study it even more. Make sure you know it like the back of your hand, like your name. Bam, must know. Let's look at it again. Let's take a quick look through it before we go off to see if we touch everything today. All right. Yeah, we did some translation today. All right, we did some translation today. Yeah, we did some enlargement. We did the enlargement question. Right, with the scale factor was -2. We're not doing the enlargement era question. So tomorrow, one of the first things we're gonna do is an enlargement era question. All right, one of the first things we're gonna do tomorrow is a question we're gonna use this thing right here. So cool, we're gonna use that thing right there tomorrow. One of the first thing we're doing tomorrow is that enlargement area. I'll make sure so we'll cover everything, But we did all of these things for the most part, except enlargement area, right? And whenever I do no fraction scale factor, where the thing gets smaller, right? We did the one with a 2, I think, with a -2, and the thing invert. And we also did a +2 with the pentagon, where they get larger and twice, right? So I make sure so we touch up everything. All right, so for the reflections now, we did a question with the y equal -x2 question. No, with the y-axis reflection, with the x-axis reflection, with the reflection to the origin, with the 180 rotation, with the y equals x and with the y equals -. So we use up all of these. Let's make sure we touch all of them, So with the question with this, and with the question with that, right? And with the question with that, and the question we have to describe the rotation, right? We never do none of this. Yeah, we do a glide reflection a while ago. We just finish a glide reflection, right? We never do we do 2 reflections over intersecting lines. At the first question, we did that. We never do any of this today. So maybe tomorrow, we touch a question, we can do 2 reflections over parallel lines, right? So the 2 things we have to do, we mark them in red. You guys can remind me tomorrow, We have to do an enlargement question tomorrow, enlargement transformation, enlargement area of enlargement, enlargement area, we have to do 2 reflections of a parallel lines. We have to make sure so we touch those 2 tomorrow. All right. Make sure so we touch everything. Show you how we deal with questions with all these things. You better get comfortable. All right. What we do 2 transformations today. We do multiple questions. Like for example, M followed by L is LM. We do a question like that today. And we do the inverse transformation today. We'll use the inverse matrix and a question. Remember with the N? Yeah, we do a question with the N, we'll use the inverse matrix. All right, and we have to calculate the inverse matrix using 1 over determinant times the adjoint, and then we have to multiply the inverse matrix by the image point to get the object point. So you see, almost all the questions that we did today, there's something on the must-know sheet relating to it. Right? So the must-know sheet, I tell you, it covers everything, almost everything that they'll ever ask you. I'm not gonna say everything, but I'm pretty confident, 99.99999% of everything that you need to know in transformation is covered right here in this must-know sheet. If you understand and you know everything in this must-know sheet right here, so you basically can do any transformation question. I'm telling you, you'll be able to do it if you understand everything that is here. Right? Remember, for the transformation, for the compound transformation, where you can form a single matrix, you can't form a single matrix if a translation is involved. I will never have anything like that today, but we did 2 of those in the last class when the translation was involved and we couldn't form a single matrix because of the translation. All right, so making sure we're covering all the things that you need to know for this topic. All right, because as I told you, it's one of the topics we can get 2 questions on the exam paper on. You can get one on section 1, where you get the diagram like we did today, a diagram question like this one, for example, that we did over here, right? And you can also get the ones where you have to do the calculation with the matrices, right? And we saw some of those as well. We're using up these matrices in here, right? All those transformation matrices and the enlargement matrix as well, all right? So tomorrow, just remind me tomorrow if I don't remember that we have to do an enlargement area question, a question with the enlargement area. I also want to do a 2 reflections of a parallel lines question tomorrow. So we could get those out the way first, so you can understand how we apply these things. All right. So that is it for today, guys. Remember, watch over about the video. Redo every question that we did today. Do them over again by yourself. Use the video as help. Any question you did not finish, or any question you don't get right, watch over the video and do them again. Everything important. We don't know what coming on the exam, so we have to be prepared for everything. Anything that's set on the exam, we have to be able to do it. So watch over the video and do over the questions. Redo the questions. Don't know whether wait too late. Just do it this evening. Take a little break and thing, and then just do it this afternoon. Get it out the way. I know you have other subjects to do, but just make some sacrifice. Sacrifice some time that you use and waste time doing something that is not important, and just do these questions. We want to make sure that we can crush the transformation question that's coming on the exam paper. It is inevitable, you know. Transformation come on every exam paper, you know. Transformation is on every exam paper. Either it come in section 1 and section 2, or it come in section 1 alone, or it come in section 2 alone. But it come on every exam paper. And tomorrow, I'm going to show you an exam paper that it come on every exam paper. Tomorrow, I'm going to show you some exam papers tomorrow. We're going to actually do some questions of some real exam papers tomorrow and show you. Right? You're preparing for an exam, you have to understand the exam, you have to know the culture of the exam that we're preparing for. Don't go in there blind. You have to know how the exam is structured, what the light is set, and prepare ourselves for it. We know the exam that we're going to do, you know. So it doesn't make sense to act like we don't know the exam that we're doing. We know the exam that we're doing. So we have to prepare for the exam that we're doing and prepare in a way that basically set us up for success in the exam that we're doing. So we don't go in the exam random and we just learn some things and go in and hope. No, we're not going to the exam hoping. We're going to the exam knowing that we're going to crush it because of the level of preparation that we're doing. We're preparing for an exam, and once we do the right preparation, we will crush that exam and get our ones with straight A's. It's a 1 with straight A's subject, believe me. Some persons start the class late. Trust me, don't worry yourself. We're gonna revise all these things, right? If you come late, you miss some stuff. For example, you never learn matrices, so the transformation might be a little bit difficult for you to get fully. Or maybe you miss the first couple of classes in transformation, so these classes not so clear. We're gonna revise these things, and we're gonna do 1 million questions of them. Let me say 1 million questions, I'm serious, you know. We're gonna do plenty more transformation questions before the exam. We'll start doing our exam preparation in March. We're gonna finish the syllabus by about between mid and the end of March, and then after that is straight exam preparation. Do you know what exam preparation? We're revising everything, and solidifying everything. We'll have one-on-one persons who are not getting certain things. We'll sit down with them and go through. Don't worry yourself. Just start learn what you can learn from now. Learn from where we are now, and you'll catch on the other things as we go forward. I've had students who start class with me like in January and put in the work and get them on the street is just the same. All right? So don't worry yourself, man. I know you kind of maybe anxious or whatever, but trust me, man. We're gonna work through it, and we're gonna make sure that we cover all the bases. So those who come in late, don't worry yourself, man. We can conquer it just the same. We're gonna learn everything we need to learn, do everything we need to do, and the revision is where you're gonna catch up on these things. Just make sure that anything that we do going forward, you catch it. Don't leave too many things that you want to have to learn in the revision period. So some persons will have plenty work to do in the revision period because they started late. Some persons won't have so much things to do because they've already covered the basis. So those who need plenty work in the revision period, we will do that plenty work in the revision period. Right? Because in the revision period, we'll be doing like 3 or 4 full exam papers every week. 3 and 4 full exam papers we'll be doing every week between March and May. Old exam paper and new exam paper and exam paper with me make and me set up specially to emphasize certain things. So don't worry yourself. Students who worry about whether them going to know or not. And so trust me, man, don't worry yourself. We're going to catch on everything and you'll all be fine. Just do everything I'm telling you now. And you're good. Once you do everything I'm tell you, like I'm say, study and know everything on the must know sheet. Just do everything I'm tell you, and you'll be fine. I'm say go and work over the question them again. Do the same example that I do in the class. You'll be fine. Just do everything I tell you, and you will be fine. Everything will come together and end. Like filling out a puzzle, and we're putting in little pieces one by one. Eventually, I don't know what the final picture of the puzzle is until you finish it up. But as we get close to the end, everything will become clearer and clearer and clearer until at the end, or by the time we get to the exam, everything clear as day, and you'll be very confident going into the exam room because you'll be well prepared. If you do everything I'm gonna tell you. All right, so I'm gonna stop it there for today, guys. So that is it. Oh, yes, still very good.
Yes, Dad.
Yes, sir.
All right,
Yes,
so
sir.
good. Beautiful. All right, so watch over the video now, and tomorrow pick it up again and go and practice and solidify this topic some more. So we have 2 more days of working questions and solidify this topic even more than we have already. I know that you learned a lot today. I know that usually happens, you know. This class usually make people understand a lot more things than they did before. So I know, and you'll understand even more tomorrow and Wednesday. All right? And we're moving on to a new topic next week, Sunday, which is vectors. All right then, bye. See you all tomorrow afternoon.
Bye,
Bye,
sir.
Dad.
Later, sir.
Sir.
By the way, tomorrow I have a meeting tomorrow afternoon starting at 1 o'clock. I don't know what time that meeting will finish. So I might have to start the class a little bit later than normal tomorrow, but let us see. I'll let you know before we start. All right? I'll just
Yes,
telling
sir.
you from
Yes,
now.
sir.
Okay,
All right.
sir.
All right, cool.
Yes.
All right, bye.
Bye,
Bye,
Dad.
everybody.
Bye.
Bye, princess.
Bye,
Bye,
sir.
everybody. Okay,
Bye,
cool.
sir.
All right, bye. Cool. All right, I'm gonna end it now. Bye. All right.